Introduction to Seasons. The changing of seasons is a fundamental aspect of life on Earth, influencing weather patterns, plant growth, and animal behavior. The cycle of seasons, spring, summer, autumn, and winter, is caused by the tilt of the Earth's axis and its orbit around the Sun. Earth's tilt and axis. The Earth is tilted on its axis at an angle of approximately 23.5 degrees. This tilt is the primary reason for the changing seasons. As the Earth orbits the Sun, different parts of the planet receive varying amounts of sunlight at different times of the year. This variation in sunlight intensity and duration causes the seasons to change. The role of Earth's orbit. While the Earth's tilt is the main factor in seasonal changes, the shape of the Earth's orbit also plays a role. The Earth's orbit is not a perfect circle but an ellipse, meaning that the distance between the Earth and the Sun changes slightly throughout the year. However, this change in distance is not the main driver of seasons. Rather, it's the tilt of the axis that leads to the significant differences in temperature and daylight. Solstices and equinoxes. The solstices and equinoxes mark key points in the Earth's journey around the Sun and are directly related to the changing seasons. The summer solstice, around June 21st, is when the northern hemisphere is tilted closest to the Sun, resulting in the longest day of the year. The winter solstice, around December 21st, is when it is tilted farthest from the Sun, leading to the shortest day. The equinoxes, occurring around March 21st and September 21st, are when day and night are of equal length, signaling the start of spring and autumn. Hemispherical differences. The seasons are opposite in the northern and southern hemispheres. When it's summer in the northern hemisphere, it's winter in the southern hemisphere, and vice versa. This is because when one hemisphere is tilted toward the Sun, the other is tilted away, resulting in different seasons at the same time of the year. Seasonal variation in temperature. The tilt of the Earth's axis affects not only the amount of sunlight each hemisphere receives but also the angle at which the sunlight hits the Earth. During summer, sunlight strikes the Earth more directly, leading to warmer temperatures. In winter, the sun's rays hit the Earth at a more oblique angle, spreading the energy over a larger area and causing cooler temperatures. Impact on daylight hours. The change in seasons also affects the length of daylight hours. During summer, days are longer because the hemisphere tilted toward the Sun receives sunlight for more extended periods. Conversely, in winter, days are shorter as the hemisphere tilted away from the Sun has shorter periods of daylight. Effects on ecosystems. The changing seasons have profound effects on ecosystems. Plants and animals have adapted to these changes, with many species timing their growth, reproduction, and migration patterns to the seasons. For example, in spring, many plants bloom and animals give birth, taking advantage of the warmer weather and abundant food supplies. Human adaptation to seasons. Humans have also adapted to the changing seasons in various ways, from agricultural practices to cultural traditions. Many cultures have festivals and holidays that correspond to the solstices and equinoxes, celebrating the return of light in spring or the harvest in autumn. Conclusion. The dance of seasons. The change of seasons is a result of the Earth's tilt and orbit, creating a predictable cycle that has shaped life on Earth for millions of years. Understanding this natural rhythm helps us appreciate the intricate connections between our planet's position in space and the life it supports.